So here we've got example 3.2. And what are we going to do for this one? So our circuit for this one looks something like this. We've got a power supply. We've got a resistor. We've got a resistor coming over. We've got this. We've got a power supply coming out. A resistor coming down. And then we've got a current supply, current source up there. All right, this is going to be 4. This is going to be 18. This is going to be 2. This is going to be 2, 4, 8. So this one is kind of cool. This is using a super node. So we're going to solve it very similar to the last ones. But we have a super node here for this one, which is going to make it a little more exciting, a little more interesting. Let me pull up that. So for one, we're going to do our normal roots. Make ref node. All right, so we're just going to pull this out. Ref node done. 2, we're going to label node voltages. Node voltage. All right, so what do we have for this one? We've got 1 over here, which is an easy one. We're going to call that Vs because it's the voltage of the source coming out and through. Cool. And then over here, we've got 1 and 2 with the source in between. We can make this even easier, though. We can pull this whole piece out and make this one giant node, which is what we're going to do. I1, I2, I3, I4. And how do we do that? Well, we know everything coming into a part of a circuit has to be the stuff coming out. So we know this is all going to be equal. I1, 2, 3, and 4 are going to balance themselves out based on the rest of the circuit and the source. So we can make a super node here, which is really kind of cool because it's going to simplify things a lot. So let's just do that. Let's leave it there. 3, draw currents. We already did that. Draw currents. We just did that with I1, 2, 3, and 4. 4, solve easies, solve easy nodes. So we have our Vs, that's our easy one, and Vs equals 4. Nice and done. Cool. And now we're going to do 5, solve nodes with KCL. Okay? So how are we going to solve this set of nodes? What are we going to do with this set? We are going to look at, first off, the node analysis, which is going to say stuff coming into a node equals stuff coming out. Current coming in equals current coming out. So I1 plus I2 plus I3 plus I4 equals 0 because they're all coming out. So this is going to be that equation. Now we're going to look at I1. We go from I1 over here, so that's going to be V1 minus Vs, V1 minus, and we have Vs is 4, so minus 4 divided by the 2 ohm resistor. Done. That's I1. Plus I2 equals V1 over 4. Done. We got that one. That's easy. Plus, if this is V1 again, and this is V2, we're going to jump over to V2 here. And what are we going to do for V2? We're going to do V2 over 8. Nothing else there. V2 over 8. That's an easy one. And then we're going to do, it's 2 coming in backwards from this. So this is going to be minus 2 or equals 2 because we're going to push it to the other side of the equal sign. Nice and easy. So this is our first equation. Now we need to connect the V2s and the V1s. And how do we connect them? What is this? Well, it's exactly what it looks like. What is the difference, the voltage drop or voltage gain between the two? Well, between V1 and V2, we have an 18-volt source. It's that easy. It's V1 plus 18 equals V2. That's our second equation. Equation 1, equation 2. So if we multiply this one out by what's the least common, let's do 8. This is going to equal, what is this? 4v1 minus 16 plus 2v1 plus v2 equals 16, and that's going to simplify out to, what is that, 6v1 plus v2 equals 32, 16, yeah, I did that right, cool. So these are our two equations, 1 and 2. Let's just star them, star, star, star. So now we set our little matrix up again. V1, V2 number, that's going to be bump, 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 bump equals bump, our solution. So our V1, that's our first one, we've got positive, minus, minus. So 1 minus 1 minus 18. And for this one, we've got positive 6, 1, 32. That's an easy one. 6, 1, 32. And if we type that out on our calculators, we're going to get 220. And the 2 is going to be V1, and the 20 equals V2. And that's going to be A, like we always do, A to the minus 1 times B equals answer. Cool. That one wasn't too bad. So the main difference of this one is, instead of solving 1, 2, 3, 4, 5, 6, we can get rid of 2 of those, and we get rid of 2 of those, and we pop one more equation in there. It makes it a little bit easier to solve. We'll look at a couple more of these coming up soon, too.